The screen is visible. Is the screen visible? Anyone? Please reply.
Yes, sir.
So in the previous class, we have already completed the third and second unit, that is called analog instruments. We have completed. So I'll ask one question about that, all of you. If you have completed the task, please raise your hand. Okay, and raise the hand. How many of you have completed assignment number 1? Anyone? Can you raise? Assignment number 1. After completing the chapter, I was given the assignment. 5 members, they have raised their hand. 1, 2, 3, Viras, Vinayak, Prajakta, Santosh, Kartika, Rupesh, Namrata, Shreya, Amit Jadhav, Pooja. What about others? Out of 38, only 9 members you have completed the assignment number 1. See, I will give one suggestion to you people. After listening this one, you only decide that you have to write the assignment or not. I don't know about your diploma and all the things, but here, as a CC for the A division, I am the CC for the A division, but CC for you people is answer. Then also we'll sit together and then we'll finalize the term work marks. While doing that one, your all attendance, your assignments, chapter test, ISC marks, these all we are going to consider. We have a particular formula. Based on that, we are going to distribute the marks, and it has priority. We are going to give assignment, even lab book also. The subject is there, for POE is there, practical oral examination. So we have 50 marks term work, sorry, practical oral examination, and 25 marks term work is there. So listen carefully and you decide on that one. You have to write the assignment or not. But one more, after completing the or starting of the unit, I am going to give the assignment. I will not ask you to upload now, but after completing the syllabus, all assignment I will ask unit wise, chapter wise. I am going to ask the assignments. On that time, you have to upload that one. Otherwise, you will lose the marks, and you have to maintain the attendance also. Remember that one. Now 5 members only left. Okay, raised their hand. So do you know the second assignment questions? The starting I was displayed, I think. I have shown already, yes?
Yes, sir.
So all of you have note down, or can I show once again? We'll finish the second unit part first, then we'll go for the third unit. So assignment booklet, all of you have already, it is there with your hand. Okay, everyone have the assignment booklet already. So in the teaching diary itself, it is there. If you don't have, you click on the teaching diary where our recorded videos are available. Based on that, in that one, I have mentioned that the assignment booklet and MCQ booklet I have mentioned already over there. The screen is visible. Assignment booklet. See here. The first assignment already I have given. The second one, see some in the Is it audible? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
What is happening here? Okay. See here, analog instruments. During the some sessions, I have given the assignments, all these assignments and all the things. Yes, I have given some assignments. See, considering that, don't concentrate on these problems and all the things. While writing that, I will not give much more questions. See here, PMMC instrument you have studied. You would write the construction and working of that instrument. If you prepared construction and working of that one, based on that one only MCQ questions will come. And single phase electrodynamometer power factor meter is there. This one, and this is again, which is that one? Explain the power of in single phase circuit by using 2 voltmeter method. It is not necessary actually. 2 wattmeter method is very important over there. 2 wattmeter method you have to write down. Have you? How many questions I have given? Can anyone read those questions? See here, total 15, 16 questions are there. I will not mention you people. So this is here, shunt type ohm meter is there. You have to choose every topic one chapter, one question you would choose that one. First PMMC you choose one question. Moving iron instrument, one question. And electrodynamic EMMC, one question. Sends and multipliers, one question. Power factor meter, whatever it may be, single phase or 3-phase, and that is moving and iron, any one you can write. And last one, frequency meter. Here 6 topics are there, and ohm meter is there, megger is there, and which is earth tester is there. 6 plus 3, 9 questions are there here only, and one more extra questions you can write down. At least for this second unit, it is very bigger chapter. 10 theory questions you have to write down. 2 wattmeter method, one more you take that one. So total 10 theory questions you have to write, all equipment. First one is on you write. How many questions I have given? Anyone tell the number?
8.
Assignment number 2.
8 questions.
कब दिया था मैंने?
22 January.
Okay, no problem. So, two more questions you add, any which topic is missed over there, add on that one, and by seeing the PPTs and notes provided, you can check that one. And some questions are mixed with third unit.
तुमचं ते लिंकचं ऍप्लिकेशन आहे पण ते तुम्हाला सगळं नीट पाहिजे ना, तुम्ही तुमच्या कॉलेज पे जावं, कॉलेज पे झेरॉक्स सेंटर असेल जवळपास कुठे तर तिथे तुम्हाला सगळं मिळेल असं बोलला. आणि एटीएम बद्दल म्हणलं की
ऐश्वर्या
माणूस
गायकवाड, Aishwarya, what you are speaking? So some third unit also, it has some second unit questions. So don't write that one this year. In the third unit, they have mentioned, explain how megger is used in the insulation testing. So this some only 2 questions are only mixed over there. Write that one. See, for the third unit, before starting the first, I will discuss the third unit introduction. I will start, then I will give the assignment questions of the third unit. Then we will go for the theory part of that one here. See here, the unit is visible, PPT is visible.
Yes, sir.
So
Yes, sir.
now we'll go for the unit 3, that is called potentiometer and bridges over there. See, already we have studied this one. Then also, see, this topic is very interesting topic actually. In the research laboratories, we are going to use these equipments. Potentiometer and bridges are there for the measurement of voltage and current, we can call that one here. That is potentiometers we are going to use. And for the bridges, we can use the what are the basic circuit elements? Can anyone tell what are the basic circuit elements? Circuit elements are what? How many types of loads are there then? The basic loads, load types. You can tell me.
resistance and inductance.
Resistance and correct,
Inductive.
correct. Go on, madam. Go on. Resistance and
Inductive load.
inductive load. Next one more.
Capacitive.
Capacitive.
Capacitive. Very good. So resistive, inductive, capacitive loads we are using means, see, mainly the circuit elements are resistance, inductance, capacitors. Resistor, capacitor, and inductors we are going to use here. So once we have provided the supply means, we'll give the voltage, and because of that supply source, the current will start to flow in the circuit. The loads are resistance, inductance, and capacitance are there. See here, from the potentiometer we can measure the voltage and current we can measure. From the bridges we can measure the resistance, inductance, and capacitance we can measure here. So for that reason, the different bridges circuits are there. So example, DC and AC, mainly the potentiometers are classified into DC potentiometers and AC potentiometers, and the bridges are also again classified into two types, that is the DC bridges and AC bridges here. Now in the DC bridges we are going to use the DC bridges for the measurement of resistance, and AC bridges are used for the measurement of inductance and capacitance. So the DC bridges are, example, Whitson bridge we are going to discuss, Kelvin double bridge we are going to discuss, and the AC bridges are, we are going to discuss the Maxwell inductance bridge, okay, Searing bridge, then De-Sauty bridge, Wayne bridge, like that. Some 3-4 types of bridges are there. These all the things we are going to discuss in the third unit here. So the main objective of this chapter to study for you peoples is to understanding purpose here. Now different methods of measurements are there for the resistance, inductance, capacitance, and as well as the voltage and current here. Now so to make you peoples to understand various methods for measurement of resistance, inductance, capacitance, and you can analyze the various measuring bridges and some potentiometers. You can analyze that one. If you know the value, if you know the circuit, then you can analyze that one, which type of bridge it is, which one is accurate, why we are going to calculate this one, like that. So that is just for the objective, main objective. But after studying this subject, the outcomes it will comes from you is, you can analyze the measuring bridges. You can analyze that one, Kelvin double bridge and Whitson bridge. You can compare that one, which one is accurate, which one is applicable for the low resistance, which one is applicable for the medium resistance, high resistance, like that. You can analyze that one, and you can apply the operation and construction of various measuring bridge here. Now the which bridge, what are the terminals are there, which type of that is a single bridge or two bridges are there, which terminal we have to use the resistance or capacitance or inductance combination we can use, like that. You will understand the operation over there. We can apply the knowledge in the real-time applications here. So some two objectives are there. Based on this objective, after studying the syllabus, you will get these outcomes here. So main syllabus here now. First we are going to discuss principle of DC potentiometer. Potentiometer means what? Then the DC potentiometer. In that DC potentiometer, the practical theory or laboratory potentiometer we are going to call, that is Crompton's type DC potentiometer we are going to discuss, and applications of DC potentiometer, and last AC potentiometer here. So these are the 4 points are related to the potentiometer, and next we will go for the bridges. The bridges are again classified into DC bridges and AC bridges. Yes. AC bridges and DC bridges over there. So the DC bridges are Whitson bridge, Kelvin double bridge for the measurement of resistance. AC bridges are used for the measurement of capacitance and inductance. I told for the inductance measurement, Maxwell bridge, Hayes bridge we are going to use for the, and Searing bridge. Sorry, for the capacitance we are going to use De-Sauty and Searing bridges we are going to use here now. So this is the syllabus of the third unit here now. It has mainly two parts are there, two parts of the syllabus. One is this part is completely related to the potentiometer here. This is related to the potentiometer. And the next term that is called completely related to the bridges here. Now this part, it is completely related to the bridge circuits are there here. This is the bridges circuit. In these bridges, for the understanding purpose, this bridge is, if you understood first bridge, then other bridges will easily understand that one. The process is same only the value or whatever the terminals are there, branches will be changes, but the method or procedure is same for all the bridges over there. Okay, so this is the syllabus. Note down the third assignment. I will give now only. Before starting the syllabus only, if I'll give the third assignment, then it will become easy for you peoples. How I will explain, like that you have to complete before completing this chapter. All the related. First question, huh? Will you note down the? I will take the first on potentiometer. I'll take that one. With a need sketch, first this one you have to write with a need sketch. You can note down if you have the assignment booklet, means you can note this one here. This is the 15 number. First question you have to write with the need sketch. Explain the laboratory type potentiometer. Explain the laboratory type potentiometer. That is the first question. Rating is on now. That is the only one is enough for that one. Explain simple DC potentiometer for measurement of unknown. This is second one. Explain simple DC potentiometer for the measurement of unknown EMF. Unknown EMF. Number 2, 17th one. 17 one, 15 and 17. 15th question, 17th question. I will also note down. Next we'll go for this one here at the start. Current through galvanometer, explain two applications of DC potentiometer, saying which Anderson bridge, where it is. How the syllabus will complete, based on that, you go that one. Explain the Maxwell inductance and capacitance bridge also. This is one number you take down. This one also you take down, number 1. Second one, third one, third one, fifth one, seventh one. This is already over. 1, 2, 3, 4, 5, 7 and 15, 7. 1, 2, 3, 4, 5, 7, 15, 17, 15, 17. लिख रहे क्या नहीं?
Yes, sir.
Maker is not necessary. Explain the DC potentiometer for the measurement of penetration, determine the resistance and inductance of the arm. I will not give the problems. I will solve 1, 2, 3 problems in the class. Kelvin double bridge, have you taken? Have you taken the Kelvin double bridge? Strain compensation techniques. Okay, that's it. 1, 2, 3, 4, 5, 6, 7, 8. 8 questions are there, na? Total 8 questions are there.
Yes, sir.
So these 8 questions you write down. I will check that one. How many bridges are covered? Maxwell is over. Whitson is over. Kelvin is over. This one. Whitson 2 हो गए क्या? 2 बार हो गए. This fourth one you cancel it. Unbalanced is there. Actually, unbalanced you have to do the star delta connection, whatever you have studied that one. Fifth one is okay. Anderson bridge. Explain two applications of. Seventh one is okay. Saying okay. D-Sotis bridge is there anywhere? Whitson frequency meter. Maxwell. This one you take 16 already I have given, na?
No, sir.
16th one you take down. Hayes bridge 16. 16. Kelvin double bridge यार है वो बस ठीक है. These 8 questions you write down. 1, 2, 3, 5, 7, 15, 16, 17. So 8 questions you have to solve. This run your syllabus only. I have given this one. Okay. Total so many questions are there. 8 questions, and in the any 2 problems you solve that one. I will solve in the classroom. Those problems also you can solve that one. While doing the session, while conducting the session, I will solve some problems. Based on that also you can consider that one. So with this you have to write how many MCQs? 8 questions plus 20 MCQs you have to write down. Any 20 MCQs you have to write. 8 plus 20 MCQ questions. See, your exam is on based on MCQ questions, but ISU we are going to conduct on writing theory part. You have to write in a paper. You have to upload that one. But exam will be on MCQ based, multi-choice question based. Questions will come. If online exam is there, okay, maybe online is there, but don't know about that. So, have discussed the introduction of the subject, syllabus, and chapter 3, and we have given the assignment. Next we will go for the actual introduction of the potentiometer. Means what? Introduction of potentiometer here now. See, a potentiometer means we are going to measure an unknown value of voltage or current. Normally we will consider as voltage only. Unknown voltage we are going to measure, but that measured value we are comparing with known value. That is called potentiometer operation. We are going to measure the unknown voltage. We are going to measure first, but that value is correct or not. How we are going to identify? So we have to cross verify, or we have to compare that value with the known value. Already standard value is there. We can compare with that one. That is called potentiometer. See here, the potentiometer. A potentiometer is an instrument. It is an instrument first of all, and designed to measure an unknown voltage here. This potentiometer is designed to measure the unknown voltage we have used here. To measure the unknown voltage, they have designed this circuit here. But whatever the unknown voltage measured here, that is by comparing it with a known voltage here. Now we are going to give the known voltage, then we have to identify that one, if it is correct or not. We have to compare with that one here. That is called potentiometer. So the unknown voltage may be supplied by a standard cell or any other known voltage reference. So see how we will do that one. If we are using the knob of the voltage source, we are going to use, suppose 20 volts we are going to use. By connecting the voltmeter, we can connect that one. We can identify that one, how much voltage is there. So based on that, we can do that one here. See here, here the 2 volt source supply is given. 2 volt supply is given. Here the scale we have given here. Now By scale means this is the sliding wire is there, sliding contact, like a variable resistance. So the difference between the normal resistance is it has two terminals, which is connecting from one to another. But how we'll take the variable resistance? We can take the strands here. No, we can take the middle of that resistance value, that is variable here. No, like that, the variable or sliding contract we are using here. No, by adjusting this one, we can connect this one into here. By adjusting, moving here, no, up to how much resistance you have to choose. Based on that, if I am going to hold here, then what is the voltage between this one here? From here to here, how much voltage is there? We can identify that one. That is called potentiometer. We are going to call here. We have to compare this one with a known value. With a known value. Why people are leaving the meeting? Some people they are leaving, some people they are joining online. See here, this is whatever we have, just introduction I told. What is the principle? How the what do you mean by potentiometer? How it is going to operate? What is the principle of basic DC potentiometer? We are going to give with example. We can consider that one here from this diagram with example. See here, we have considered one uniform cross-sectional area conductor. We have considered here. This is the conductor here. Whatever. Just a minute, I will draw the conductor here. This is the conductor I am going to use here now. It has uniform cross-sectional area. Uniform cross-sectional area it has over there. Okay, this is uniform. You can consider anywhere it is the area of this cross-sectional area of this one will be same. This one will be equal here now. So it has constant cross-sectional area. We can call that uniform means all the throughout that length of that conductor, it has only one cross-sectional area. There is no, that is if the thickness of that one will be the area cross-sectional will be more after 2 meters, 1 centimeter. It is not like that. It is throughout this complete from A to B, the cross-sectional area of this conductor AB is uniform only here. It is same only we are going to consider. If a wire of uniform cross-section area is carrying a steady state current here. Now, steady state current means this is the value of current. It is constant current. It is going to carry over there. Okay. So the current it is carrying here now. Next. Then fall of potential across any portion of the wire is directly proportional to the length of that portion here now. See, I want to measure the voltage between at this point to this point here. At this point to this point, I want to measure the voltage here. Okay, I want to measure the voltage here. So this voltage drop, whatever it is there, I will consider this one as X and this one as Y. So the voltage drop across VXY is directly proportional to this length here, no, LXY, whatever the length is there, that much value only it is going to consider here. That much value only it is going to consider here. So example I will give here. How it is, voltage is directly proportional to the length. We can give the example here. All of you know the formula of Ohm's law? Do you know the formula of Ohm's law? Anyone can you tell me, state Ohm's law? Any one of you can state the Ohm's law statement you give me. See, if you know the answer, you don't tell me yes, sir. You tell the answer directly. Instead of saying yes, you can tell the answer. I told you people, don't hesitate to give the answers. Whatever it may be, we are not giving any award. We are not, what is that one? Punishing you people for the wrong answer. For the correct answers, we will appreciate that one. For the wrong answer also, we will appreciate that one. If you have given the correct, we are not going to give awards. If you have given the wrong answer, we are not going to punish you. So why you people are hesitating to give the answer? Tell me the formula of Ohm's law.
is
V
equal
equal
to IR.
V is equal to IR here. Okay, IR. See here, I told we are using a uniform cross sectional and steady state current we are using here now. The potential across here carrying a steady current. So the current is constant here. Yes or no? The current V is equal to IR. The current is constant. So I will leave this one here now. Next, what is the formula for the R? Laws of resistances. Anyone can you tell me?
Rho L divided by A.
R equal to rho L by A here now. So I will keep this I as it is here now. I will use the rho. This is L divided by A here now. What do you mean by rho? This one specific resistance it is.
Yes, sir.
Yes, this is the specific resistance. It is a constant here now. Okay, and I told here now this is the total length of this AB is LAB. I will use here. The length is LAB. I am going to use here, but I am not going to measure the voltage across this complete voltage VAB. I want somewhere it is now. Okay, but suppose one more. Just give the minute. I told that one. The conductor, this conductor, it has throughout A to B, it has a constant cross-sectional area only, uniform cross-sectional area only. Here also its cross-sectional area is same. Here also its cross-sectional is same. Here also it is same. Yes. So it is a constant only. It is not dependent on voltage and current. Yes. It has uniform cross-sectional area. So area is also constant here now. And here current is steady. It is also constant. The specific resistance is also constant here now. The resistivity of the resistance. So what is the left? V equal to. So we can say that one, if it is constant, I will consider this all three things as a proportionality constant, and we can draw that one. V is directly proportional to what? What is the left term here now? Varying term here now. The length we can consider this much, we can consider this much. But from here to here, I want to measure the voltage, means the length will be changed. But what about the area? Area is same only.
Yes, sir.
And current here, current I is flowing here now. Either current I1 flow again. Here 2 ampere it is flowing, means if the current is same, current will flow here also. Yes. The cross-sectional area is constant here. Then the current is also constant. The specific resistance throughout the cable or conductor is constant. So we can write V is directly proportional to L. Yes. So the voltage drop across a specific point here now, that is called equal to the, that is directly proportional to the length of this one here now. Length of this one. It is directly proportional to the length of this one here now. See here. Then fall of potential across any portion of the wire. Any portion of the wire is directly proportional to that length of that portion they are telling here now. Length of that portion. That is the basic principle here now. See here. One more example I will give you people. In a month, how many days are there? In a month, 30 days in a month are there. Okay, 30 days is there. Okay, per month it is 30 days. 30 days are there. Okay, I will write just a minute. 1 month equal to 30 days. Okay, per month salary is 60,000. You just imagine you have 60,000 rupees salary per month here now. Per month salary is 60,000. Okay, so for some 2-3 months you will work regularly. for the complete month, you will get 60,000 and all the things. Suppose in between, instead of 30 days, what you will do in a month, you will be absent for 10 days over there. Will absent for 10 days. So only 20 days you are going to attend the office here now. 20 days you will work, another 10 days you will absent for the company work. What is your salary? They are going to pay 60,000 to you?
No, sir.
No? How much they are going to pay then? How much they are going to pay then?
40.
40,000 only. How you have calculated this 40,000? So your salary is directly proportional to the number of days in a month.
Yes, sir.
Yes, sir.
Your salary is directly proportional to the number of days in a month. Like that, the voltage drop is here, whatever the voltage drop across this AB is there, that is your salary. VAB is your salary here now. So the total length of this conductor, it is number of days in a month here now. This is per month here. LAB is there, that is your month, number of days. The voltage drop across this LAB is, that is your salary here now. Suppose you want to calculate the salary for first 10 days only, 10 into, how we will calculate that one? For the 10 days. So total salary is 60,000 for 30 days. 60,000 divided by 30 into 10. Yes? 60,000 in divided by 30, it will give 1 day salary. Into 10 you have done, means that is the value of this, how much voltage drop is there for the next first 10 days. Like that, how much resistance is there up to there from the A to C, we have to calculate here now. So this voltage drop across A to C is directly proportional to the length of from A to C only here now. It is not proportional to the AB here now. Length of A to B, it is directly proportional to the length of AC. Length of AC here. So to understanding purposes, I have used here now. See here, ये diagram ये कैसे use किया ऐसा मत बोलो. So this diagram I will simplified form I will write here now. So you just consider, I will consider one cable here now. See here, this is the uniform cross sectional area. Circuit is there. Okay. Next, what we have to do, I will, that is a conductor. That is a conductor here now. I will give here, I will give that red color. I will take that one. That one is chocolate color chicken. So I will give here one battery source supply. I will provide here, and one variable resistance I will provide here. Stop there. I'll provide here variable resistance here now. This is RSH. This is RSH. This is battery supply, that is called E. And this is A to B here now. This one we can consider as A, and this one we can consider as B here now. B here now. See here. The same thing we have drawn here now. This circuit diagram is there, whatever it is. This one, same like we have formed this one here now. So this is the total length LAB here. One conductor we have used. We have given some supply from the battery supply volt, and we have used one rheostat, that is variable resistance, to limit the current. This one here now. Steady state current set करने के लिए we have used this variable resistance here now. By varying this one, we will set the steady state. One current will set that one. So throughout the circuit, the same current it will flow over there. So that is called I here now. The current I we are going to set by varying this one here. So next, the current will flow from here, same throughout the conductor. The current is constant only. The current is constant only. And the cross-sectional area of this conductor anywhere in the through from A to B, it is also constant only. It is also constant only here now. So the voltage drop across A to C here now. I will mark this one. I want to measure the voltage drop across A to C. Then that VAC is directly proportional to the length of conductor from A to C here. That one we have to prove here. This is the basic principle we are of DC potentiometer we are going to consider here. Same thing they have explained in the next diagram. They have explained here in the explanation here. This is the explanation. Consider a wire AB of uniform area of cross section here. Now we have considered a wire that is called AB, which is having a uniform cross sectional area, carrying a steady state current I as shown in the figure here. Consider a portion AC equal to L here. This AC we are going to consider as L here now, and of the wire here. Suppose potential difference across AC is V. That voltage drop across this length L is V we are going to consider. Then that is fall of potential across the length L of the wire is V. Second one, if A is area of the cross section of the wire and rho is the resistivity of the wire, then resistance of that portion equal to R equal to rho L by A. We already know that the laws of resistances, the resistance is directly proportional to the length of the conductor, inversely proportional to the cross sectional area, and directly proportional to the specific resistance, or what is that one? Property of the material, we can call that one. Directly proportional to the property of material, we can call that one. We know the formula, and according to Ohm's law, we already know the formula that is called V equal to IR here. V equal to IR, we know the formula here now. So I is steady, we have considered here now. Here steady current I is there, steady current I is there here now. So the R place, in this place of R, you substitute this one. In this place of R, you substitute R equal to rho L by A here. So substituting in the place of R, rho L, A, we have substituted here now. So from this equation, we can say that I is constant, rho is constant, A is constant, but the length is varying here. Now we can consider full AB, sometime we can consider 25%, 30%. Based on that, the V is directly proportional to L. Based on this principle, the potentiometer it is going to operate. Potentiometer is going to operate. Suppose I have to draw 100 kilometers. 100 kilometers we are going to measure. Then we have to, for 10 kilometer, how much voltage is there? We can measure that one. Based on the length of that conductor, we can measure over there. Length of that conductor, we have to measure over there. So example, I think salary example I have given, that is all of you have understood that one, I think. Okay, suppose one more example I will give. You are starting your journey from Pandharpur to Solapur, you are going to start. Okay, Pandharpur to Solapur, you want to go over there. Okay, Pandharpur to Solapur. What is the bus fare from Pandharpur to Solapur? Bus charge kitna is? Okay, I will consider as 100 rupees is there. 100 rupees bus fare is there from Solapur to Pandharpur to Solapur. आवाज आ रहा है क्या?
Yes, sir.
Yes, sir.
So I have total the bus I want to go to somewhere. So I will sit in the Pandharpur bus now. This bus I will sit down here now. So the bus is going from Pandharpur to Solapur. So around 70 kilometer distance is there. 70 kilometer distance. Okay. So the bus charge is 100 rupees. Okay. But I will sit in this bus only. But I will get out from this bus at Mohol only. Mohol, I'll get out from that bus here now. I want to go to the Mohol, but the bus is going from Pandharpur to Solapur. But I want to go to the Mohol here now. They will charge 100 rupees for me.
No, sir.
Half. How they are considering then?
45 rupees.
45 or whatever it may be, 45 or 50, whatever you consider that one. So based on the kilometer you are going, that one only they are going to consider.
Yes, sir.
So the length of from Pandharpur to Solapur is 70 kilometer, but the Mohol is, you can think that one, that is for 35, 40 kilometer, you can think that one. So for the 40 kilometer only they are charging the money. So like that, the potentiometer is operating. So the length from A to B is, that is Pandharpur to Solapur, the distance is there. But I want to measure the voltage across up to the C point, that is called up to Mohol only, how much charge they are going to calculate. That we here now. Voltage drop across that one only I will calculate. Means this voltage drop is directly proportional to the length of that distance here now. That wire conductor length here now. Like that, your bus fare is directly proportional to the distance from Pandharpur here now. That is the principle of potentiometer. I think now samajh mein aaya sabko.
Yes, sir.
Yes. Any doubts you have?
No, sir.
So this is the concept of DC potentiometer. This is the concept of DC potentiometer. Tomorrow we'll explain about this diagram here now. This is the actually circuit diagram. This is just principle we have discussed here now. Basic principle of DC potentiometer we have discussed, and circuit diagram of basic slide wire potential, its construction, working, and next we will go for the Crompton type potentiometer. Okay. If you have any doubts, you can ask me. In this diagram, the diagram is looks differently, but the circuit diagram, equivalent diagram I have drawn and I have shown you, given the examples. Any doubts?
No, sir.
So it is, I'll take the attendance just a minute. Roll number 1, roll number 4, (11), 17, roll number 17, 19, 21, 22, 23, 24, 25, 6, 7, 28, 29, 30, 31, 33, 34. Oops, I know, 34. Roll number 34. Are you there? Roll number 24 is also present. Satyam Gade. इनका नाम इधर नीचे कैसे आ गए? EESYB24. हाँ. Okay, no problem. So once again, I will repeat roll number 1, roll number 11, 17, 19, 23, 25, 31, 36, 37, 38. These are the absent numbers. Okay. We'll stop here only and we'll continue in the next class.